Good morning, students. So let us continue with the same chapter. The question reads, in the figure given below, two circular flower beds have been shown on the two sides of a square lawn ABCD of side 56 meter. If the center of each circular flower bed is the point of intersection O of the diagonals of the square lawn, find the sum of the areas of the lawn and the flower beds. Okay, so let's understand the diagram. So in this case, if you see ABCD is a square, yes, of side 56 meter and its diagonals are meeting at the point O. Yes, if you see here AOB is nothing but a quadrant of a circle. So AOB is a quadrant of a circle. I did not draw it properly, but it is a quadrant of a circle. Yes, and the diagonal, half of the diagonal will become the radius of the quadrant. Yes, so I hope this is clear. So with this concept, so let us start solving the problem. Area of the square is nothing but side square. Side has been given as 56, so it will become 56 square, that is 3136 square centimeter. So we need to calculate the diagonal of the square. Why we are calculating the diagonal of the square is because we need the radius for calculating the area of the quadrant of the circle. So which happens to be root 2 into sides, that is root 2 into 56. So radius of the quadrant will be root 2 into 56 divided by 2. Yes. So area of the quadrant will be pi r square by 4. So that is 22 by 7 into root 2 into 56 by 2 whole square, because that is the radius, into 1 by 4. So 22 by 7 into 2 by 4 I will get, into 56. Root 2 square will be 2. So 2 square will be 4. 56 square will be 56 into 56 into 1 by 4. After doing all the calculations, I'll get 1232 square centimeter. Area of the shaded region equals to area of the quadrant minus area of the triangle AOB. If you see in this diagram properly, so area of the shaded region will be what? So area of the quadrant minus the area of the triangle AOB. So we have to consider that. So area of the shaded region equals to area of the quadrant minus area of triangle AOB. So area of the quadrant, anyways, I have found it to be 1232 minus half into base into height. If you see in this diagram, half into base into height for that AOB. AO is the height, OB is the base. Yes, and both its value will be equal to the radius of the quadrant, that is root 2 into 56 by 2 into root 2 into 56 by 2. So I'll get 1232 minus half into 2 into 56, because root 2 into root 2 will give me 2. 56 into 56 I've written 2 into 2. So after doing all these calculations, I'll get 1232 minus 784, that is 448 square centimeter. So because I'm having two shaded region, if you see here properly in this diagram, I'm having two shaded region. So that's why I'll write area of two shaded region equals to 2 into 448, that is 896 square centimeter. So therefore area of the lawn and flower beds equals to area of the square plus area of the shaded, area of two shaded region. 3136 plus 896, that is 4032 square centimeter. So here, if you see the diagram, we have to find the area of the circle we have found, and area of the shaded region. If we can find, add it up, we'll get the answer. So that's why I write 3136 plus 896 as 4032 square centimeter. So let us take the other example, other question. In the figure given below, a square OABC is inscribed in a quadrant OPBQ of a circle. If OA equals 20 centimeter, find the area of the shaded region. Use pi equals to 3.14. I have been stressing upon this. I've been stressing on this. If pi value has been given as 22 by 7, use 22 by 7. But if it has been mentioned 3.14, we have to use 3.14. Yes. I hope this is clear with everyone. So just go through the problem once. Okay. So let us start. So let's understand the question with a diagram. So in this case, OABC is a square, okay, and its side is 20 centimeter. If I can calculate OB, that will form the radius of the quadrant, right? Because we know that distance from the center of the circle to its circumference happens to be the radius. So let us calculate That is also diagonal of the square. So diagonal OB of square equals to root 2 into side, that is 20 root 2. So this will also become, this diagonal will also be the radius of the quadrant of the circle. So area of the quadrant of the circle equals to 1 by 4 pi r square. 1 by 4 into 3.14, because the value of pi has been given as 3.14. That's why I'm not using 22 by 7. Yes, so 1 by 4 into 314 by 100. I'm converting 3.14 as 314 by 100. After doing all the calculations, you will get 628 square centimeter. So area of the square equals to side square. So that is 20 square, that is 400 square centimeter. Now if you see, I have calculated the area of the quadrant and area of the square as well. I want the area of the shaded region. So what my logic will be, I'll subtract the area of the square from the area of the quadrant. Yes. So area of the shaded region, as I've told you, it will be area of the quadrant minus area of the square, which happens to be 628 minus 400, that is 228 square centimeter. Yes. So let's go ahead to the next problem. In the figure given below, ABCD is a rectangle. AB equals to 14 centimeter and BC equals to 7 centimeter. Taking DC, BC and DA as diameters, 3 semicircles are drawn. Find the area of the shaded portion. Okay, so this is the diagram that I have in hand. So ABCD is a rectangle, yes, with side 14 centimeter and BC equals to 7 centimeter. Yes, if you see here, AB is the diameter of this one of the semicircle, so its radius will be half of that, and AD, that is 7 centimeter, is the semicircle, is the radius, is the diameter of the other semicircle, so its radius will be 7 by 2. I hope this is clear. So I'll write area of the rectangle we need to calculate first. So area of the rectangle ABCD equals to AB into BC, that is 14 into 7, that happens to be 98 square centimeter. So radius of the semicircle with diameter 14 centimeter equals to 14 by 2. I'm speaking about this semicircle. Yes, so 14 by 2, that is 7 centimeter. So its area of the semicircle equals to pi r square, so that is 77 square centimeter. R has been found as 7 by into 7. Yes, so radius of this semicircle with diameter 7 equals to 7 by 2, that is 3.5 centimeter. So area of two semicircles, because if you see here properly, I'm having one semicircle over here and another semicircle over here. So I'm calculating area of the two semicircle. Area of two semicircle equals to pi r square by 2 plus pi r square by 2. I can write it as pi r square. So 22 by 7 into 3.5 into 3.5, which happens to be 38.5 centimeters square. If you see here, how we are going to calculate the area of the shaded region is, I'm going to take the area of the rectangle. From there, take out the area of the bigger semicircle and add the area of the two smaller semicircle. So that is the logic which I'm going to use. So area of shaded region equals to area of rectangle minus area of semicircle with 14 as diameter plus area of the two semicircles with 7 as diameter. So I have found 98 minus 77 plus 38.5, so 21 plus 38.5, that happens to be 59.5 centimeters square. Yes, I hope this is clear with everyone. Okay, so before going into this problem, anyways, let us go through together. In the figure given below, O is the center of a circle. O is the center of a circle with AC equals to 24 centimeter, AB equals to 7 centimeter. Find the area of the shaded region. Use pi equals to 3.14. Before going into solving this problem, I need to tell you one fact which is a part of your class 10 syllabus, which says if I draw in a semicircle, if I draw any angle, in this case CAB is a triangle, is an angle inside the semicircle. In this case, CAB will always be a right angle. What I'm trying to say is, angle in a semicircle will always be a right angle. Keep that in mind, okay? So in a semicircle, any angle will be a right angle. So this is the property I'm using. Thus, angle CAB will be a right angle. So CAB is a right angle. Yes, triangle ABC will be a right angled triangle. So triangle ABC will be a right angled triangle. Yes, in triangle ABC, by Pythagoras theorem, BC is the hypotenuse, whichever contains the right angle AC and AB will become perpendicular and height. Yes, so I'll write BC square equals to AB square plus AC square. After doing BC square equals to 7 square plus 24 square, so I'll calculate BC equals to 160, that is should be under 625, pardon me for that. So BC equals to 25 centimeter. So what I have found after doing all this problem is BC is also the diameter of the circle. Yes, so which happens to be 25 centimeter. So also we need to calculate the area of triangle ABC because we have to remove the area of triangle ABC afterwards from the area of the entire circle. Yes, so I'll calculate this 84 square centimeter, half into base into height, that is half into 24 into 7 is 84 square centimeter. So radius OB equals to 25 by 2, that is 12.5 centimeter. So area of semicircle equals to 245.331 square centimeter. This you can make it very easily. Now if you see properly here over here in this diagram, this BOD is nothing but a quadrant of a circle. Okay, so quadrant of a circle. So the logic I'm going to use to find the area of the shaded region is I'm going to calculate the area of the semicircle. From there, remove the area of the triangle and add the area of the quadrant BOD. Okay, this is the logic which I'm going to use. So area of the shaded region, as I've told you, it will be area of semicircle minus area of triangle plus area of quadrant. I think I have not shown you how I calculate area of quadrant. So area of quadrant is pi r square by 4, that is 3.14 into 12.5 whole square by 4. So that happens to be 122.66 square centimeter. So after doing all this, I'll get 245.31 minus 84 plus 122.66. So which happens to be 203.97 square centimeter. Okay, girls, all these are very logical questions. Okay, just know the diagram properly, you'll get the answer. Next question says, in the figure given below, ABC is a square of side 14 centimeter. A, B, C, R, and D are centers of the equal circles which touch externally in pairs. Find the area of the shaded region. So the logic that I'm going to use here is pretty straightforward. I'm going to calculate the area of the 4 circles. From there, take out the area of 4 quadrants, this white spaces, empty spaces, plus I'm going to calculate the area of the square, and from there again subtract the area of 4 quadrants. I repeat again, I'm going to calculate the area of 4 circles. From there subtract area of 4 quadrants, plus I'm going to calculate the area of the square. From there again subtract the area of the 4 quadrants. So that is going to be my logic. So radius of the circle is 14 by 2 because the side is 14, so it will be 14 by 2, that is 7 centimeter. So area of the outer shaded region is area of 4 circles minus area of 4 quadrants. So I'm just calculating the area of the outer shaded region. Outer means outside the square. So it will be area of 4 circles, 4 pi r square minus 4 into pi r square by 4, area of 4 quadrants. So I'm going to cancel it like this. 4 pi r square minus pi r square, that is 3 pi r square. After doing calculation, I'll get 462 square meter. So after this, I need to calculate area of shaded, just pardon me, area of the inside shaded region will be equal to, I have told you, area of the square minus area of the 4 quadrants. So area of the square minus area of 4 quadrants will be equal to 14 square minus 4 into pi r square by 4. So that is 196 minus 222 by 7 into 7 into 7, that is 196 minus 1454, that is 42 square centimeter. So area of shaded region is nothing but we need to add those two things. 462 plus 42, that happens to be 504 square centimeter. Okay, so the next question, in the figure given below, the boundary of the shaded region in the given diagram consists of 3 semicircular arcs, the smaller being equal. If the diameter of the larger one is 10 centimeter, calculate the length of the boundary and the area of the shaded region. Use pi as 3.14. So this is the diagram that I have. So this length is 10 centimeter. Then the radius of the bigger circle will be 10 by 5, and the outer circle will be, the smaller circle will be 5 by 2, that is 2.5. Yes. So length of the boundary equals to circumference of the bigger circle, that means circumference of the curve. Remember, there's a slight difference between circumference and perimeter. Yes, so in case of perimeter we consider even the radius and the diameter part, but in case of circumference we consider only the curved part. Okay, so I'm going to write, so length of the boundary equals to circumference of the bigger circle, that means the curved bigger part, plus the circumference of the smaller circle, that is the curved path of the smaller circle, plus circumference of the smaller circle, again the lower part. So that's what I'm going to calculate. So we know circumference is given by pi r plus pi r plus pi r. Yes, circumference of a semicircle is given by pi r. That pi plus 2 into r was for perimeter, and this is only circumference. Keep that in mind. So pi r plus pi r plus pi r. So pi into 5, r is 5. In the second, for the smaller case, it will be 5 by 2. So that's why I'm doing pi into 5 plus 5 by 2 plus 5 by 2. Doing all these calculations, you will get 3.14 into 10, that is 31.4 centimeter. So let us calculate the area of the shaded region. So area of the shaded region will be nothing but area of the bigger semicircle, yes, minus area of the smaller circle plus area of the bigger circle. So that means I need to calculate area of the bigger circle minus area of the smaller circle, that means the white part, and the area of the shaded part, that is below the bigger circle. Yes, so I'm writing area of the bigger semicircle minus area of the smaller circle plus area of the small circle. I can cancel both of the smaller circle because both of them are identical. They are having the same radius. So I can cancel it. So I'll get area of the bigger circle only. So I'll write pi r square by 2. So pi r square by 2, r is 5. So 3.14 into 25 divided by 2. That is 78.5 divided by 2. That is square centimeter. That is 39.25 square centimeter. Yes, I hope this is clear. Next question I have is, in the figure given below, the points A, B, and C are centers of arcs of arc radius 5 cm, 3 cm, and 2 cm respectively. Find the perimeter and the area of the shaded region. Same logic we will be using. So this is the diagram I am having. It looks like a yin-yang. Same logic which I am going to use. Yes. So area of the perimeter of the shaded region equals to circumference of the semicircle. Again, same logic. Circumference of the semicircle plus circumference of the smaller circle plus circumference of the third semicircle. Yes. So I'll write circumference of this semicircle plus circumference of the semicircle plus circumference of the semicircle. That means I should have written with radius, different radius we are having. So I'll write pi r1 plus pi r2 plus pi r3. So pi into first radius is 5, second radius is 3, third radius is 2. So 3.14 into 10 again becomes 31.4 centimeter. Yes. So area of the shaded region in this case again will become area of semicircle. Area of semicircle, the bigger semicircle, minus area of the smaller semicircle plus area of the smaller semicircle. Yes. So pi r1 square by 2 minus pi r square, pi r2 by 2 square plus pi r3 square by 2. So remember, this smaller circle, I have not written it properly. The radius for the empty semicircle is 3, okay, and it is 2 for the lower part. So I'm writing pi r1 square by 2 minus pi r2 square by 2 plus pi r3 square by 2. So pi by 2 I can take it out common. 5 square minus 3 square plus 2 square, which happens to be 20. So 3.14 into 10 is 31.4 square centimeter. Okay, so let us discuss the last problem that I have. In the figure given below, ABCD is a square of side 4 centimeter. At each corner of the square, a quarter circle of radius 1 centimeter and at the center a circle of diameter 2 centimeter are drawn. Find the perimeter and the area of the shaded region. So area of the shaded region equals to area of the four quarters circles plus area of the circle in the middle. So I'll write area of the shaded region equals to area of the square minus area of 4 quarter circles with radius 1 centimeter minus area of a circle with radius 1 centimeter. Yes, 4 square minus 4 into pi r square by 4, because we are calculating quarter of a circle. Quarter means quadrant, minus pi into 1 square. So 16 minus 3.14 minus 3.14 happens to be 16 minus 6.28, that is 9.72 square centimeter. Remember girls, in this case I have not calculated perimeter because I wanted you to do it on your own, at least one problem from this chapter. So with this I'm concluding the chapter on circles. If you have any doubt, just put it across. I'm not taking any Zoom class because it's very difficult. It's becoming very difficult to take Zoom class because of the internet, as well as it's very difficult to explain this kind of things in Zoom class. So I'm free to any doubts if you have, but please make note of all these questions in your notebook and kindly submit it to me before you go for the other class. Thank you. I take your leave.